we've had some people who I've given homework to out there, all the Aetherists, and I was hoping that one of them would come out and say, "Look, let me tell you what the ether is, or let me draw for it, the ether, right? Because if you can illustrate the ether, right, or define the word, then I know what you're talking about. But if you don't define it or illustrate it, well, I have no clue whatsoever what you're talking about. What do you mean by ether whenever you mention the word?" And so this is the whole problem. The whole problem, these people start talking in the middle of the, they start their theories in the middle of the film. And they start talking about the ether as if you knew what it was. And then they say, "This is my theory." And they start with a theory. No, I don't want you to tell me your theory. I want you to illustrate the ether, or if it's a physical object, or define it if it's an abstract concept. Okay, either one, I don't care. But you have to tell me what the ether is according to you. And what these people say usually is, they give you the old, what is it? It's a mantra they have, really, that they have for God. If I knew what God looks like or what he is, then he would be so great. And these people say more or less the same thing for the ether. If I knew what the ether was, then it wouldn't be so invisible, so powerful. It wouldn't underlie everything out there in the universe. They would just come in there and and that's why they go directly to the theory, because they cannot tell you what the ether is. This is the whole problem. And yeah, an Aetherist, like I define it all the time, is a person who doesn't know what the ether is. That's the definition of an Aetherist. And so here was this fellow the other day, and this is what he put up there. He says, "I was going to draw for you the ether, but nah, you would still find something negative to say. Why would I even bother? You're nuts." Okay. Yeah, he said he couldn't draw the ether also because he wasn't a good illustrator, a good artist or whatever. And so he just ran away with the tail between his legs. Okay, so we have this fellow, he just ran away. He didn't come back to tell us what the ether is, I guess, and he's welcome to come back and tell us what the ether is. It's very simple. The doors are open. Just tell us what the ether is. Illustrate it, whatever you need to do, okay? Another fellow, he said the following the other day. He said, "Ether would be like the seed of an apple." There is your object, a seed. And there I have Johnny Appleseed, planting a seed. And from there, I guess something grows, I don't know, the world, the universe. And so, yeah, we have this situation where I showed Neil Turok and Stephen Hawking. They came up in 1999. They published an article. Essentially, they were interviewed by Astronomy Magazine. And they came up with this, the one in the center there. They said it looks like a pea, which is very much like this fellow's seed, you could say, right? And so, that's what they call it. They say it's the P instanton, okay? And I think this was primarily Neil Turok's idea, but I guess Hawking stood behind it. And this is what it looks like. This is how Neil, I guess, illustrates it. There you have the open universe, the singularity, the whole works, all there, okay, and all the steps from the Big Bang onwards. But the P instanton was out there first, okay, and that was what the Big Bang, how the Big Bang started. Okay, that's the starting point. So what is this starting point? This P, how did it get there? Well, they don't tell you that. They don't tell you what's outside of it, what gives it shape. Like in this case, the white stuff that gives shape to the P instanton, So we don't know what that white stuff is that gives shape to it. We don't know where it came from. Did God make this or what? You got to tell us a little bit more than just say, there's your P. Yeah, what can I do with it? And that's the same problem with this Aetherist who says, it looks like a pea, or a seed in his case, right? And so here it is. This is what he says. This is how he backed it up. He says, the ether is eternal. Sounds like God already, right? All objects are of the ether, although the ether is not any object. So here we are. He's saying essentially, your table is made of atoms, but the atom is not a thing, not an object. So we have a thing made out of something which is not a thing. That's more or less what he's saying there. He's saying the ether is not an object, but it makes up everything else that is an object. Okay, so that's what he's saying. Ether is not a particle, although particles are of the ether perturbed. And that is why they vibrate and have frequency waves. The ether has no space, no Cartesian, therefore it is not visible. Okay, so I guess he's excusing why he can't draw it, but then he says it's a seed. So there on the lower left you can see the seed, and Johnny Appleseed planting a seed. So he says it's a seed, that's what it looks like, but he says it's invisible, and I guess I had to draw it for him. He didn't draw it, I drew it for him, right? Okay, so he says it looks like a seed, or maybe the P instanton, or who knows what. Okay, and then he clarifies, he says, objects are not falling towards each other in gravity. They are accelerating towards the null point, that is the return vector to ether as pure potential. Ether, what is ether? It's pure potential. Then he says space is the loss of the ether's pure potential. Space is not a thing, but the absence of a thing. Well, yeah, you can't define things in the negative. You can't use an antonym to define a thing in science. Okay, you got or a synonym, right? You can't say a dog is not a horse. Well, yeah, no kidding. And what is it? Not a tree, also not a rock. Okay, where are you going to go through every word in the dictionary and say it's not that, it's not the other one, No, we can't define in terms of negatives. And so he hasn't told us anything when he says it's not a thing, because we don't know what a thing is according to him. Especially when he says that ether is pure potential. And then he continues, he says, the seed is a much better example for the ether than your thread/rope object. Okay, he says, just like the seed, its potential is lost as a tree that grows and then bears fruit, which return back to pure potential seed. Okay, and why do you keep returning to the particle luminiferous ether theory, which is wrong, and say, see, this is wrong, so there is no ether? Yeah, all I can tell you is what everybody and their mother thinks the luminiferous ether is. Okay, it's not a theory, it's called a hypothesis, it's an assumption, and the assumption is that there is this luminiferous ether out there. It's made of particles, gazillions of particles. Some people say that it's equal to space, that space and ether are synonyms. Others say the ether is contained within space, but that's what it's always been, a whole bunch of particles. And so you're the first one who says that it's a seed. First of all, you probably are the only person on earth that says it's a seed, but you're not saying it's a seed. You're just saying it's pure potential, and potential is a concept. There's no such thing as potential, and you can't say that everything is made of potential. That's irrational. That's what it's called, irrational. So you found out just now that you're an irrational individual. Okay, you don't have a case. You don't have a leg to stand on. So far we have no illustration of what the ether is, and certainly it cannot be a seed, because you can't do anything. What are you going to do? Move the seed around? What's outside the seed? Space? I mean, what is the seed? And that's when he goes into poetry and says, well, it's pure potential. Fella, you got to lay off the drugs, the shrooms. Okay, another fellow says, it says here, what did he say here? It says he's going to prove the ether. It says first, Aetherists, you just need to define what you're envisioning. Totally agree. You got to define the word, if that's what it is, a concept. Objects we point to and illustrate or show the shape, and concepts we define. So he said define it. Okay, if it's a concept, then you have to define it. No doubt about that. It seems most great physics ideas come from a creative spark internally, which must be externalized by tools like math. Weird, right? No, we don't need math at all here. has nothing to do with math. You either show us a picture of it and point to it, in which case we don't need any math, or you define the word, in which case we don't need any math either. We don't need math to know what the ether is, okay? If it's, even if it's a mathematical concept, you can always define it with words. You don't need math, okay? You don't need quantities here. The idea often comes first, then it is proven. No, in science we don't prove. That's in religion where they prove. Proof means that you convince someone of something and now he believes it strongly. Because belief is just belief, opinion, and proof, knowledge, means that you believe it more strongly. That's all it means, but you still believe it. How did Plato define knowledge? He said, justified true belief. That's what knowledge is, just belief. And justified true are both opinions. Whatever's justified, whatever's true is just an opinion. What's true to you is a lie to your neighbor. So all we had was opinions all these years for the word knowledge. Hell, one could almost say his concept of ether has been actualized by the discovery of electrons, which exist virtually everywhere. Yeah, electrons, atoms, no, electrons don't exist everywhere because you have the atoms in between them and neutrons and who knows what. So, no, to say that electrons are everywhere, you haven't solved the problem. You're not, what are you saying, that ether is just a bunch of beads, which is really my definition of the ether because it is a concept. Yeah, ether, a bunch of particles. You want to call them electrons? Okay, a bunch of electrons, no problem. But the issue is, what are we going to do with that? And what's giving shape to each electron? What's containing all this? Because if the electron is a little bead, I'm assuming that's what you're referring to, then it's got to be contained by something that gives it background. And you got to identify that background. What is it? Space? And now you got to tell us what space is, So it's on and on and on until you get your hypothesis, until you get your assumptions down, pat. We have to understand the whole picture before you go to your theory. And he said, well, we don't know. And knowledge has nothing to do with science. In science, we don't use the word knowledge. They use it in religion. Knowledge means justified true belief. And belief has to do solely with religion. So it's not a well-grounded theory. Well-grounded means knowledge again. Means that you've proven something, meaning that you believe it. That's all it is. So that's all that grounded means. We don't ground anything in science. We give an assumption, we make an assumption, and the other person has to take it at face value in order to understand the theory. So you have to be clear on your assumptions. What are you proposing before you start your theory? And then you can go on and explain your theory, your mechanism, what caused it or whatever, right, the phenomenon. Often paired with mud, flood, and flat earth. Okay, I don't know what that's all about. It's not a tall order to ask for concrete definitions of things before trying to, prove them? We don't prove anything in science. So this fellow has to take kindergarten physics 101 first, know what the scientific method is. Even that's earlier. Science 101. Okay, so let's get on with these other issues. So we'll finish there with ether. We'll see if some of these guys come over and give us an idea of what the ether is. And by what, I mean draw it, illustrate it. If you can't illustrate it, or you say it's not a thing, it's an object, a body, a medium, good. If it's not that, then it's a concept. Then you have to define the word. Very simple. So all etherists are welcome to take that homework and come here when they have it completed. Okay, let's move on to our other issue here, and that is the subject of today. And we're going to be doing a little bending of light. We're going to use mass, okay? But first, we're going to begin with a bending of light that does not involve mass, which is strange because, in one scenario, they use mass, and in the other one, they do not use mass. They use something called diffraction, or like in this case, this fellow, refraction. Okay? And so you have these two worlds, the microscopic world where they do not introduce mass, and you have the macro world of general relativity, string theory as well, where they introduce mass. So we have the mass and the massless. Okay, so let's begin with the massless, so that you can get start getting into the hang of things, get the hang of things, so you see how they treat these subjects. We're going to go with the massless first. Here it is, and it's got to do with this. The other day I mentioned that you had this balloon, that the astronaut carries to space, and the balloon pops. Okay, the balloon pops, and the air comes out. We color coded it so that you could see it. Okay, and so we want to say the only thing we want to say about that is, does that blob have shape or not? It's a yes or no type of question. It's not, what is the shape of a blob? No, that's not the question. The question is, does a blob have shape? Okay, that's the question. Okay, it's a yes or no type of question. These fellows, one guy and another, they went and drifted out and talking about, whether the last atom and how does it flow and stuff that really was irrelevant to the subject matter that we discussed. And so here you see it says, if a balloon in space pops, right? What is the movement pattern of the gas released from the balloon? He's talking about the movement of the gas. Well, who cares? I mean, I don't care. That wasn't the issue. The issue was, does that have shape? Does that blob of air to the last atom there, right? In the blob that's expanding, right? Does that blob have shape? And the answer hopefully is yes if you have eyes, right? In fact, even if you don't have eyes, it does have shape by definition, okay? Does it move around like a small cloud, or does it disperse outwards like the hypothetical Big Bang? Or what would it be? Does a gas hold itself together or disperse into molecules? Well, gases tend to expand. I think that's what this other fellow answered. He says answered him. Liquids and gases take the form, shape of the container. Absolutely not. Okay, absolutely not. The air molecule inside of a balloon would be moving at roughly the speed of sound or slightly faster. No, we do not need a container to give shape to things. And this is a big misconception that people have out there. And again, here we're going to take the astronaut back up there because people seem to have problems understanding this. We're going to take, gas, any gas. In this case, I called it air. You can call it whatever you want. You want to use, some inert gas, whatever, like argon or whatever. It doesn't matter. Just color code it so that we know what we're talking about. The balloon goes out there. The astronaut goes out there with a balloon. He's got some gas inside that balloon. Okay, and so far it's got the shape of the balloon, whatever gas is in there. He pops the balloon, and out comes the gas. Okay, it's color coded. We can now see it. It has shape. And so the only issue is, does that white stuff that you see on the third frame of the film, right? Does that have shape? And hopefully the answer is yes for anyone. And you say, well, what is the shape of that? Well, no, it's a blob. So it's got blob shape. Okay? We don't care what the shape of it is. The issue is, does it have shape? And hopefully the answer is yes. So does the pop balloon, by the way. They both have shape. Okay? So you don't need a container because space is not a container. And you can see it has shape despite not having a container. Okay? So this balloon is expanding. The gas is expanding, and we don't care if it's expanding or not. We take a snapshot at a given point in time, right? And hopefully something comes out in the picture that you took. Okay, so yeah, it does have shape. It's got blob shape, and we don't care what the shape of it is. We're just saying it does have shape. Therefore, that whole thing, that whole blob, is known as an object, as a thing. Hopefully anything made out of atoms is a thing. Okay? So I think it's straightforward. I mean, I don't know what kind of problem people might have in understanding what I'm saying. I think this is straightforward, unless you have some kind of mental block and can't conceptualize what I'm trying to tell you here. Okay, here's one fella, and he's struggling to understand what an object is. So yeah, some people are struggling, and I'm sorry for all those of you who understand it already, but I've got to go through with some of these folks because they're having trouble understanding something as simple as what is an object, what is a thing, what is a medium, right? What is an agent? And here it is. So it says, I'm manufacturing jawbreakers in space. It has a hole in the center that was made in the vacuum of outer space, okay? We bring it back down to Earth, okay? We bring it down to Earth. The hole has the form, shape of its container. Sphere, circle, yeah, it could be a cube, doesn't matter. So he thinks that it has, the hole itself has shape because it's trapped within the container. And so the hole has the shape of the container. If it was a cubic container, the hole would be, cubic. And if it's a spherical one, the hole would be spherical. That's what he's got in this poor fellow, that's what he's thinking. That's the way thinking, I guess you can call it thinking, lack of thinking, right? Is the hole an object? Of course not. And yeah, we agree there. The hole is not an object. But why isn't it an object, okay? And here we have, let's see if Bugs Bunny can teach us a lesson today, okay? Here we have Bugs Bunny, okay? He's in the middle of nowhere, okay? And, I guess out in the field somewhere. And you can see that he's in a hole. The hole is dark, black, you could say. Let's call it black, okay? And he's in the middle of a field, and he's just sitting there, right, with his arm on the ground. But does the hole have shape? That's the question. And a lot of people would say, well, yeah, the hole has shape, like a shadow has shape, right? And the answer is no. What has shape is the ground, okay? And so just so that you don't get confused, let's remove the ground, okay? We're going to remove the ground, okay, and find out the hole has shape. And here it is. That's what was underneath the ground. We took the ground, we put good old bugs out there in space, and you can see that, the hole disappeared. There was no hole. Okay, what was there was ground, not hole. Okay, and let's show it again one more time. Here it is. There's good old bugs, right? And he's just sitting there, right? And people think that the hole has shape, and it doesn't. It's got to be a standalone thing. And here, let me show you what I'm talking about. Here we have an angel, right, with what is known as a halo, usually a plate or a ring around his head, okay? And the question is, is there a difference between a halo and a ring? And yeah, the answer is yes. A halo is not an object because it's a dependent object, much like in the case of Bugs' hole, the ground served as the object, and people confuse the hole with the ground. They think both of them are objects. And no, the object was the ground, not the hole, okay? And here we have a more or less the same situation. The halo is a dependent object, you could say, just to talk in those terms. It's not really an object, but it's a concept because the halo has the holiness built into it. It's a holy ring, and a holy ring is not a ring. A holy ring is a concept, okay? If we remove the angel, like you see on the right, all we have is a ring, okay? We don't have the angel anymore. So that's a standalone object, and we call it a ring. The other one is not a standalone object because in order to call it a halo, we had better have the angel underneath. Okay, so that's the issue. And so, yeah, in the case of bugs, the hole is not the object. The object, if you go far back, you will see the shape of the ground, and the ground looks like a donut. That's what it is. It's got a hole in it. It's a donut, okay? Or whatever, maybe a cube with a circle in it. But the hole is not the object. The object is we'll call it the donut, right? That's the object. And we prove this very simple by getting rid of the donut and see if the hole remains. And you'll find out that the hole is a dependent object, meaning it's a concept like the halo. It depends on the donut. Without the donut, no hole. Very simple, okay? For some people. For intelligent people, okay? And the fellow says here the following. He says, with AI art, you can force the AI to illustrate vacuum of space, ether, and all those hogwash fake things metaphysicians believe in. Yeah, with some of this technology like ChatGPT and so on, you can start questioning a lot of stuff that mathematical physics has proposed over the last 100 years. Because now you can feed it to the ChatGPT and this robot will give you an answer. And the question is, what are you going to put for, transfer energy? I mean, you can program some of these things and say, well, if you program energy as a physical object, some kind of smoke or whatever you want to put in there, a cloud, and you say, I transfer energy. The computer understands that. But if you are very careful with your language and you say you transfer energy, but you do not illustrate, the ChatGPT, the computer, will not know what to transfer. You know, what are they going to transfer? You got to put something for the energy if you're going to give the computer an instruction to transfer something. And I think you can put a lot of the stuff into ChatGPT, you know, a lot of the concepts that they're transferring and, you know, wave the wave. What are you waving? A bunch of vectors? You know, you have vectors, you know, magnitude and direction, transverse wave. What are you going to put? You know, unless you draw it. Then the computer will know what to transfer. Say, I'm transferring this bunch of arrows. That the computer understands. But then you have to be careful that you're staring at a bunch of vectors and not arrows, not engine arrows. You know, so he says the AI won't explain to you how it works, though. Maybe ChatGPT will try to explain mechanisms to you, but we'll end up parroting the usual bad arguments of modern theoretical physics. Yeah, one of the problems there is a lot of this stuff is programmed by the mathematical physicists and programmers who learn the same nonsense in college, right? And so, yeah, he ends up saying, at this point, it's better to argue with AI than with these people. The things they write read like AI anyway. Yeah, so all I can tell you is that a lot of these people, they program the chat GPTs, the robots, the AIs, all that stuff, and they just put in there what is the worldly wisdom, which comes from mathematical physics. But I challenge them to transfer energy, to move the mass, to wave the wave, to shake the field, you know. And what are you going to put? You got to draw something for the computer to understand it. It's got to be an object. It's got to have shape. Then you can wave you can excite the field, move the mass, transfer energy. Then you can do that. But if you don't put an object there, what will the computer understand? What will it shake? What will it move? What will it transfer? And that's what you got to think about.